2.3 Separating the components of a mixture. We have learned that most of the natural substances are not chemically pure. Different methods of separation are used to get individual components from a mixture. Separation makes it possible to study and use the individual components of a mixture. Heterogeneous mixtures can be separated into their respective constituents by simple physical methods like handpicking, sieving, filtration that we use in our day-to-day life. Sometimes special techniques have to be used for the separation of the components of a mixture. 2.3.1 How can we obtain colored component dye from blue or black ink? Activity 2.4 Do this. Fill half a beaker with water. Pull a watch glass on the mouth of the beaker. Put a few drops of ink on the watch glass. Now start heating the beaker. We do not want to heat the ink directly. You will see the evaporation is taking place from the watch glass. Continue heating as the evaporation goes on and stop heating when you do not see any further change on the watch glass. Observe carefully and record your observation. Comment this. Evaporation. Vapors, ink, watch glass, beaker, water. Now answer. What do you think has got evaporated from the watch glass? Is there a residue on the watch glass? What is your interpretation? Is ink a single substance pure or is it a mixture? Comment this. We find that ink is a mixture of a dye in water. Thus, we can separate the volatile component solvent from its non-volatile solute by the method of evaporation. 2.3.2 How can we separate cream from milk? Nowadays, we get full cream, toned and double-toned varieties of milk packed in polypacks or tetra packs in the market. These varieties of milk contain different amounts of fat. Activity 2.5 Do this. Take some full cream milk in a test tube. Centrifuge it by using a centrifuging machine for 2 minutes. If a centrifuging machine is not available in the school, you can do this activity at home by using a milk churner used in the kitchen. If you have a milk dairy nearby, visit it and ask 1. How they separate cream from milk and 2. How they make cheese, paneer from milk. Comment this. Now answer. Comment this. Sometimes the solid particles in a liquid are very small and pass through a filter paper. For such particles, the filtration technique cannot be used for separation. Such mixtures are separated by centrifugation. The principle is that the denser particles are forced to the bottom and the lighter particles stay at the top when spun rapidly. Application. Used in diagnostic laboratories for blood and urine tests. Used in dairies and home to separate butter from cream. Used in washing machines to squeeze out water from wet clothes. 2.3.3 How can we separate a mixture of two immiscible liquids? Activity 2.6 Do this. Let us try to separate kerosene oil from water using a separating funnel. Pour the mixture of kerosene oil and water in a separating funnel. Let it stand undisturbed for some time so that separate layers of oil and water are formed. Open the stopcock of the separating funnel and pour out the lower layer of water carefully. Close the stopcock of the separating funnel as the oil reaches the stopcock. Separation of immiscible liquids. Separating funnel, kerosene oil, water, stopcock. Applications. To separate mixture of oil and water in the extraction of iron from its ore. The lighter slag is removed from the top by this method to leave the molten iron at the bottom in the furnace. The principle is that immiscible liquids separate out in layers depending on their densities. 2.3.4 How can we separate a mixture of solid and camphor? We have learned in chapter 1 that camphor changes directly from solid to gaseous state on heating. So, to separate such mixtures that contain a sublimable, volatile components from a non-sublimable impurity, the sublimation process is used. Some examples of solids which sublime are ammonium chloride, naphthalene and anthracene. Separation of camphor and salt by sublimation. Cotton plaque, inverted funnel, solidified camphor, vapors of camphor, mixture of camphor and salt, china dish. Separation of camphor and salt by sublimation. 2.3.5 Is the dye in black ink a single color? Activity 2.7. Do this. Take a thin strip of filter paper, draw a line on it using a pencil approximately 3 cm above the lower edge. Put a small drop of ink, water soluble, that is from a sketch pen or fountain pen, at the center of the line. Let it dry. Lower the filter paper into a jar or glass or beaker or test tube containing water so that the drop of ink on the paper is just above the water level, as shown in figure, and leave it undisturbed. Watch carefully as the water rises up on the filter paper. Record your observation. Comment this. Strip of filter paper, line drawn by pencil, a spot of ink. Glass rod, paper clips, jar, strips of filter paper, a spot of inks, water. B. Separations of dyeing in black ink using chromatography. Now answer. Comment this. The ink that we use has water as a solvent and dye is soluble in it. As the water rises on the filter paper, it takes along with it the dye particle. Usually a dye is a mixture of two or more colors. The colored component that is more soluble in water rises faster, and this way the colors get separated. The process of separation of components of a mixture is known as chromatography. Chroma in Greek means color. This technique was first used for separation of colors, so this name was given. Chromatography is the technique used for separation of those solids that dissolve in the same solvent. With the advancement in technology, newer techniques of chromatography have been developed. You will study about chromatography in higher classes. Applications: to separate colors in a dye, pigments from natural colors, drugs from blood. Two point three point six. How can we separate a mixture of two miscible liquids? Activity 2.8. do this. Let us try to separate acetone and water from their mixtures. Take the mixtures in a distillation flux, fit in with a thermometer, arrange the apparatus as shown in. Heat the mixtures, slowly keeping a close water at the thermometer. The acetone vaporizes, condenses in the condensers and can be collected from the condenser outlet. Water is left behind in the distillation flux. Thermometer, clamp, distillation flux, water outlet, clamp, water, condenser, mixture of acetone and water, cold water in acetone. Separation of two miscible liquids by distillation. Now answer, comment this. This method is called distillation. It is used for the separation of components of a mixture containing two miscible liquids that boil without decomposition and have sufficient difference in their boiling points to separate a mixture of two or more miscible liquids for which the difference in boiling points is less than 25 K. Fractional distillation process is used, for example, for the separation of different gases from air, different fraction from petroleum products, etc. The apparatus is similar to that for simple distillation except that a fractionating column is fitted in between the distillation flux and the condenser. A simple fractioning column is a tube packed with glass beads. The beads provide surface for the vapors to cool and condense repeatedly, as shown in figure. Fractional distillations: thermometer, cork, water outlet, water condenser, pure liquid component, cold water in, cork, mixture, distillation flux, clamp, fractionating column. Two point 3.7. How can we obtain different gases from air? Air is a homogeneous mixture and can be separated into its components by fractional distillation. The flow diagram figure shows the steps of the process. Air compress and cool by increasing pressures and decreasing temperature. Liquid air allowed to warm up slowly in fractional distillation column. Gaseous get separated at different heights. Oxygen, argon, nitrogen. Boiling point 0 degrees Celsius, minus 183, minus 186, minus 196. Percent air by volume 20.9, 0.9, 78.9. Flow diagram shows the process of obtaining gases from air. If we want oxygen gas from air, we have to separate out all the other gases present in the air. The air is compressed by increasing the pressure and is then cooled by decreasing the temperature. To get liquid air, this liquid air is allowed to warm up slowly in a fractional distillation column, where gases get separated at different heights depending upon their boiling points. Answer the following. Arrange the gases present in air in increasing order of their boiling points. Which gas forms the liquid first as the air is cooled? Comment this. Separation of components of air. Filter, air in, air under pressure, hot air, water out, freezing cold water in, cold compressed air, separator, carbon dioxide out as dry ice, liquid air, expansion, jet, nitrogen out, argon out, fractional distillation column, liquid oxygen. How can we obtain pure copper sulfate from an impure sample? Activity 2.9. Do this. Take some approximately 5 gram impure sample of copper sulfate in a china dish. Dissolve it in minimum amount of water. Filter the impurities out. Evaporate water from the copper sulfate solution so as to get a saturated solution. Cover the solution with a filter paper and leave it undisturbed at room temperature to cool slowly for a day. You will obtain the crystals of copper sulfate in the china dish. This process is called crystallization. Now answer, comment this. The crystallization method is used to purify solids. For example, the salt we get from seawater can have many impurities in it. To remove these impurities, the process of crystallization is used. Crystallization is a process that separates a pure solid in the form of its crystal from a solution. Crystallization technique is better than simple evaporation technique as some solids decompose or some, like sugar, may get charred on heating to dryness. Some impurities may remain dissolved in the solution even after filtration. On evaporation, this contaminates the solid. Applications. Purifications of salt that we get from seawater. Separation of crystals of alum Fitkari from impure samples. Thus, by choosing one of the above methods according to the nature of the components of a mixture, we get a pure substance. With advancements in technology, many more methods of separation techniques have been devised. In cities, drinking water is supplied from waterworks. A flow diagrams of a typical water works is shown in figure. From this figure, write down the processes involved to get the supply of drinking water to your home from the waterworks and discuss it in your class. Water purification system in water works. Reservoir to allow solids to settle. Sedimentation tank to sediment the suspend impurities. Loading tank, fine sand, water, gravel, coarse gravel, filtration tank, chlorination, chlorination to kill bacterium, to home. Questions. Comment this.